Something unusual is emerging from the frozen Earth in Antarctica, and it could alter the laws of physics. The physicists do not know exactly what it is, however, they are aware that it is some type of cosmic ray, a high-energy particle that has traveled across space into the Earth and back out again. However, the particle is known to physicists, the collection of particles that comprise what scientists refer to as the standard model (SEM) of particle physics, should not be able to do this. There are neutrinos with little energy that can pass through miles and miles of rock without being impacted. However, high-energy neutrinos and other high-energy particles possess huge cross-sections. This means that they will nearly always collide with something shortly after entering the Earth and never escaping. Hello everyone, and welcome to another video. Today we'll be looking at something inexplicable is happening in Antarctica. Yeah, you heard it right. NASA's Antarctic Impulsive Transient Antenna, ANITA, a balloon-borne antenna moving over the southern continent, reported two incidents in Antarctica in March 2016 in which cosmic rays indeed erupt from the Earth and were detected by NASA's Antarctic Impulsive Transient Antenna, ANITA. ANITA is designed to chase cosmic rays from outer space, so the high-energy neutrino community was ecstatic when the instrument found particles that appeared to be erupting from the surface of the Earth rather than speeding away from it. Because cosmic rays shouldn't behave this way, scientists began to question if these strange beams are composed of never-before-seen particles. Since then, physicists have proposed various explanations for these upward-going cosmic rays, including sterile neutrinos, neutrinos that rarely collide with matter, and atypical dark matter distributions within the Earth, referring to the mysterious form of matter that does not interact with light. All of the proposed possibilities were intriguing and suggested that ANITA may have found an unaccounted for particle, but none of the answers established decisively that the signal at ANITA could not have been created by something more mundane. A new publication submitted to the preprint server RxIV on September 26 changes this. Penn State University astrophysicists determined that there had been more high-energy particles traveling upward than there were detected during the two ANITA events. They stated that IceCube, a larger neutrino observatory in Antarctica, had observed identical particles 3 times, but no one had yet tied these events to the ANITA enigma. In addition, by integrating the IceCube and ANITA datasets, the Penn State researchers determined that each particle erupting from the Earth had a probability of less than 1 in 3.5 million of being a part of the standard model. Depending on which of their computations you examine, their results have statistical confidence levels of 5.8 and 7.0 sigma. The principal author of the current paper, Derek Fox, stated that he first encountered the ANITA events in May 2018 in one of the earlier papers that attempted to explain them. I thought, well, this model doesn't make much sense. Fox told Live Science. However, the ANITA result is quite intriguing, so I began investigating it. I began discussing with my office neighbor Stein Sigurdsson, the second author on the study, who is also a Penn State student, whether we might be able to come up with more convincing explanations than those presented in previously published papers. Fox, Sigurdsson, and their co-workers began searching for similar occurrences in the data collected by other detectors. When they discovered plausible upward-going events in the IceCube data, he added that he realized that he may have stumbled upon something that will revolutionize physics. "This is what physicists live for," he remarked, adding, "This is what really got me excited about the ANITA experiments, breaking models, imposing new limits on reality, and discovering previously unknown facts about the cosmos." As previously reported by Live Science, experimental high-energy particle physics has been stagnant for some years. In 2009, when the 17-mile-long, $10 billion Large Hadron Collider was completed on the border of France and Switzerland, scientists believed that it would solve the mysteries of supersymmetry, the theoretical class of particles that may exist outside of current physics but have never been detected. According to supersymmetry, every standard model particle has a supersymmetric partner. Researchers suspect the existence of these partners because the masses of known particles are not symmetrical with one another. Seda Ipek, a particle physicist at UC Irvine who is not involved in the new research, remarked, "The standard model explains a multitude of occurrences really well, but it still has a number of flaws. For instance, it cannot explain the presence of dark matter, neutrino masses, or the universe's matter-antimatter symmetry." In 2012, the LHC confirmed that Higgs boson, the last undiscovered component of the standard model. After that, it ceased to identify anything significant or intriguing. Researchers questioned if any existing physics experiment could detect a supersymmetric particle. Jesse Shelton, a theoretical physicist at the University of Illinois at Urbana-Champaign, told Live Science in May, around the same time that Fox got interested in the ANITA data for the first time. "We need fresh ideas." Now, a number of scientists who were not part of the Penn State study told Live Science that it provides good, though insufficient proof that something new has arrived. Mauricio Bustamante, an astrophysicist at the Niels Bohr Institute at the University of Copenhagen, who was not involved in this new study, stated it was clear from the beginning that if the ANITA anomalous events are caused by particles that propagated through thousands of kilometers of Earth, then those particles were very likely not SM particles. The research published today is the first thorough evaluation of the improbability that these events were caused by SM neutrinos. He added, "Their findings substantially contradict an SM explanation." Bill Lewis, a neutrino physicist at Los Alamos National Laboratory who is not involved in the publication but has been following studies into the ANITA incidents for several months, stated, "I find it extremely persuasive." So that's all from today's video. If you enjoyed it, remember to leave a like, subscribe, and ring that bell icon so that you never miss our upcoming videos. And don't forget to share your thoughts in the comments section down below. Stay tuned, and we'll catch you in the next video.